Hey everyone, thanks for coming to my presentation today. My name is Randy. I'm a software engineer at Blockstream, and today I'll be exploring covenant-based atomic swaps on the Liquid network. So for those of you who don't know what an atomic swap or a covenant is, don't worry, because I will be giving some background on the topic before jumping into the code. So let's just get into it and start with the first question I'd like to answer, which is, what is an atomic swap? If you look in the Bitcoin wiki, it describes the problem of an atomic swap as follows. The problem of an atomic swap is one where at least two parties, Alice and Bob, own coins and want to exchange them without having to trust a third party, which could be a centralized exchange in this case, right? So I have my own definition. It's pretty similar. It's an atomic swap refers to the process of exchanging one asset for another without having to trust the person you're swapping assets with. And just to provide some historical context, because I thought it would be a little interesting, Jeff Garzik was the first person I could find that posted about atomic coin swapping on Bitcoin Talk. It was in the context of colored coins, which is an early protocol launched in Bitcoin's earlier days. So the concept of an atomic swap has been wrestled with for a while. That's what this shows, or I try to show. So what are some examples of an atomic swap? There are a lot of ways to perform atomic swaps in the Bitcoin ecosystem that you've probably even performed yourself without knowing it, at the time. So for example, swaps from on-chain UTXOs to Lightning locked Bitcoin are called submarine swaps. These swaps are used in popular wallets like Moon and are accomplished via the usage of HTLC's hash time lock contracts, and are pretty popular form of swaps in general. So HTLCs here all stand for hash time lock contracts. I've provided this diagram to try and make it easier to follow. If you don't know what submarine swaps are, it's just an example that's used a lot. So I numbered these steps that we can go through together. For submarine swaps, Alice makes an on-chain HTLC that is scoped to Bob, and then Alice gives an invoice with the HTLC hash to Bob. Bob will basically try and pay it. Alice should reveal the HTLC to receive the payment, and the secret behind the HTLC, Bob should be able to use to redeem on-chain. Thus, as long as Alice successfully receives the HTLC, Bob should get that secret, by the way of how Lightning works. And there's also reverse submarine swaps, which I don't really get into. And another contentious topic in the Bitcoin ecosystem has been inscriptions. But one of the interesting things that I've seen about inscriptions is they also have this form of atomic swaps with regard to swapping their sats, right? And they use something called partially signed Bitcoin transactions, for short PSBTs. And they use it, this is like giving an offer to sell. And these work by specifying an inscription for sale in one input, in this case, input 1, and not input 0 to avoid spending the inscription, and specifying the payment output at the same index. So right here, the input is then signed such that it can only be spent when the specified output is spent with it. So this payment and this spend of the inscription have to happen together. And this essentially works because of the signature scheme that they use, which is SIG single, and anyone can pay. But in summary, the maker essentially assigns the input and output corresponding to their inscription and payout respectively, and the buyer taker has to deal with organizing the rest of the inputs and outputs. So yeah, this signature scheme is pretty cool. It allows us to make signatures that remain valid when other inputs or outputs are added. And then the taker of that offer must then fund the PSBT with the amount of Bitcoin specified by the maker's output. So here in input 2. And then they're also responsible for sending the inscription to themselves in output 0, and then sending any change back to themselves in subsequent outputs not covered, by signatures from the original seller. But yeah, these are, I don't know, I thought it was a pretty cool application of PSBTs, surprisingly, from the inscription community. So let's answer the next question, which are, what are covenants? George Maxwell is said to have coined the term in a post on Bitcoin Talk titled Coin Covenants Using SCIP Signatures, an amusingly bad idea. If that title sounds a bit negative to you, wait until you hear his first usage of the word, which is right here. He theorized a particular sort of rule could take the form of requiring any output script pub key to be of the form this validation key and whatever rules you want. And by doing so, you have effectively created a coin which is forever subject to a covenant which will run with the coin and forever constrain the use of it and its descendants, degrading its fungibility. So it sounds pretty negative, right? Forever constraining coins and reducing fungibility is a bad thing, right? And for some, it definitely is, but luckily we've learned a lot since then. For example, covenants, we've defined them to, not always be a forever encompassing thing. You don't need to forever encumber coins and reduce fungibility. And whatever risks associated with covenant locked coins are minimal, is I think this conclusion what a lot of community has gotten to. At worst, you can just consider them burned, which you can already do on the main chain today. But I also wanted to go over a more modern definition of covenants that has been posted more recently. And it's here. This is from Andrew Polstra. He writes in his Medium post, Cat and Schnorr tricks, that covenant is a hypothetical Bitcoin script which restricts the form of the transaction spending the coins. And I kind of like this definition, because when you actually think about what it means, if you've studied Bitcoin script for long enough, you'll see that there's no way to add spending conditions that rely on the structure of the outputs, or that rely on the input index the witness is executed from, or the transaction version, or the number of inputs, the number of outputs, etc. So there's a lot that could be done, with a little bit of introspection. But that's where tapscript opcodes come into the picture. Tapscript opcodes are new opcodes added to the Elements network, along with the Taproot upgrade. The added opcodes relevant to covenants are referred to as transaction introspection codes. And as the name suggests, these opcodes can only be used in Taproot script path spends. And here's a link to these extended opcodes. To make it easy, the tapscript opcodes that will be used for my short demonstration are op push current input index, which is an opcode that pushes the input index the witness is being executed from onto the stack. There's op inspect output asset, which pushes the asset ID onto the stack with an output index given as argument. There's op inspect output value, which pushes an output's value onto the stack, which also takes in an output as argument. And finally, op inspect output script pub key, which can push the script pub key of an output onto the stack. And just like the others, it also takes in an output index as an argument. So we can start getting into covenant construction, but I did want to go through some requirements first. And the requirements I'd like to go over are, I want to start with a stated objective to try and elicit some of these requirements. And the objective is, for a swap, we would like to lock funds in a covenant that checks that an output is paying out our desired asset in amount to our address. So, whether something gets spent should pretty much solely rely on whether we get what we want for it, right? And I have that this can be done by inspecting a specific output. Since we can't iteratively check through variable number outputs in script, that's not how Bitcoin and LiquidScript works. We could do that by checking that the output index chosen to pay us has an appropriate asset type. We can check that the output index chosen to pay us out has an appropriate asset value. And we could check that the output our payout index has a script pub key only we can spend from. So again, just ensuring that we have the money that we requested for the asset that we have up for offer. And if you've seen any of my Bold 2 posts on script, you may have noticed that I like to break down what's happening in a script into individual chunks. Sorry if it's a bit boring. I just wanted to be very clear about what my script is doing. Keep me up with that. I'll be splitting out script chunks into 3 sections: the output asset check, the output value check, and the output script pub key check. So the output asset check has a couple opcodes in here. Again, there's op push current input index, which I went over, pushes the input index onto the stack, and inspect output asset, op drop, because inspect output asset doesn't just put the asset ID on the stack, and asset ID, which is little endian. I put that just because of how it's implemented. I have to reverse some things, and then I do op equal verify. But let's look at the execution of the script snippet, assuming it's being used as at input index 0 of a transaction. So this is going to be the stack after the bolded part is run. And after this is run, again, we're assuming that the witness is running from input 0. So it'll put 0 into the stack. See, it's green to indicate it's added on the stack. And then let's go to the next opcode, inspect output asset. So again, it actually doesn't just put the asset ID, it puts something called a prefix, which I'm not interested in. And as you'll see, in the next opcode, op drop, will just end up dropping that. So, but this 0 gets consumed by this inspect output asset because it is inspecting the output of 0, since this witness is running from input 0. Now op drop, again, I just want to drop this prefix. I don't really need it at the moment. And output asset check is now on asset ID. It's a data push. So again, it's just added to the stack. And finally, I do a op equal verify, which makes sure that things are okay. This actually doesn't put a 1 to the stack. I guess I put it to demonstrate that it's success, but this should just fail if these two things aren't equal and do nothing otherwise. So you'll see the 1, but when you see the verify here, it actually doesn't push to the stack. I probably should have taken that out if I want to be really accurate. So now we can do the output value check. And as you'll notice, there's like a pattern in that these things are done in similar ways. So again, we just push the current input index onto the stack. We're going to get a 0. Let's go through this a little bit faster this time, since you guys have seen this pattern. Again, this has a prefix I don't care about. It's going to get dropped. Yep, now it's going to be red because it was dropped. And then we put the swap amount onto the stack, and then we run an equal verify. And again, this 1 isn't factually correct, but I just want to show success. Output script pub key check. Again, we could just kind of run through this. It's the same stuff. Output script prefix, we're going to drop the prefix, put the output script, and then we're going to check that these things are equal. Little typo here, but it's all good. So this is the full script, right? And it's pretty simple now that we know this individual components of these. This is the first part. There's different colors to show you where the boundaries are. This is the second part, and this is the third part. And this is a very simplistic covenant, because or it's trivially constructed in a way, because there's a lot more you could do with this. I wanted to get the minimal example that I could to try and demonstrate this without too much confusion. If you're new to covenants or haven't worked with script in any way in the past, but hopefully you can see it's not too hard. And so a couple of things I wanted to address before this. I just wanted to say that in some ways, covenant-based atomic swaps are a lot like PSBT swaps or in LiquidPSET swaps for elements transactions. The basic idea behind performing an atomic swap using covenants is to have the covenant enforce an output with a specific asset, amount, and destination script pub key, and put that locking condition essentially on the input that you want to offer up. The asset used to fund the covenant, which is the amount sent to the paid to Taproot address derived from the covenant script, will represent the asset being offered. So again, this is the entire script. So this is part of a couple other notes I wanted to make before I go into the code, which is why a covenant-based approach may be taken for atomic swaps, and some constraints that bind both the PSET and covenant-based approach. So one reason why you might consider doing these atomic swaps over PSETs, at least the way they're presented in the way with inscriptions, is that it really depends on the signature scheme, right? And we don't have things like sig hash group or any prev out or like anything too complicated for signature schemes that people have proposed over the years. So one cool thing about covenants is that you could specify an asset being offered and in the covenant ask for different assets back. So an example would be an atomic swap covenant placed on a single LBGC input and making it self-exclusively spendable if the first payout output is Fuji, of a certain amount, and the second is Tether, for example. Something that can't easily be done with the PSET approach that they have right now. And finally, I also wanted to say both covenant and PSET swaps do require an on-chain transaction to actually execute, right? If it's on the blockchain, it's not really final. And also an on-chain transaction to cancel. And I didn't really get into canceling the covenant. As you saw the script, it looks like there's really no way to get out of that covenant. So I did want to say you can cancel the swap. The way that Taproot transactions work is that there's something called like a key path spend, and then there's also a script path spend. And we will, in the script, have a key path spend, which will allow us to take back our funds and spend it to whatever arbitrary location we would like. And if that isn't taken, then the script path will be taken instead. And then something else to note is that actually just wanted the full script. So this is the full script we were talking about. And if you look at it, there's not really a place where we like check sig or check against someone's public key, which means that if I were to broadcast a transaction that wanted to take advantage of this script for a swap, you could technically have member of the Federation reorganize things into blocks, right? And even make their own transaction to go and fulfill this instead of the original broadcaster. So that is a risk. And if you wanted to bind it to an identity, you can do a check sig. But as the seller, that's not really a huge concern for you. As a buyer, it probably is that someone can snoop in and take your transactions. And again, that could also happen on Bitcoin in terms of the miners. So just something to note. So now that we have that, let's take a quick look at the code before I get into Q&A. And I won't be going to the code too deeply. I just want to go over the high-level summary of what's going on because you don't want to put everyone to sleep. And the code is there. It's open source. This is the QR code for it. I put it under a repo I already had just as another branch. I might give it its own repo, but all of these scripts that I write, they all have the same structure, which is why I just wanted to use a branch of this pre-existing repo. So without further ado, let's look at the code. So right out the bat, you can see that I try to maintain some type of semantic parity between the code and the presentation. So get output check, get output asset check. I mean, you could kind of see that I almost verbatim put exactly what I said I was going to put in here, right? I push the current input index, I inspect the output asset of that index, I drop the prefix, I add on the little endian asset ID, and then I check for the equal verify. And stuff like this is just me, converting things. And then again, we have the get output value check. This again does what you'd expect it to do. I have a value. It is encoded in like hex and written into a big int, but semantics are there. Push current input index, we inspect the output value, drop the prefix, and we compare the values, right? Get output script pub key. Again, same thing. I don't want to be repetitive, but I just want you to see that there's no magic really going on here. This part, I did do this subarray just because I didn't need the witness version or the push data size. Again, that's another thing that I mentioned, or I think I will mention in my next Bold2 post, how like you push data onto the stack with script and how that works with regards to the nitty gritty and the bytes. But you could kind of disregard this for a little bit and look into it more in the future if that's something that interests you. And get covenant script, I literally just put everything together. And I do put an op true at the end because, again, these are all op equal verify. That means that on success, they actually leave nothing on the stack. So I want all these checks to run. And hey, if like there's nothing on the stack, then I want it to evaluate to true. And that's what this is for. I always want it to have a true on the stack. I outlined the steps that we're going to follow in this code snippet. First thing I want to do is issue a new asset. The second thing I want to do is create a covenant with a spending condition enforcing an asset payout to an address we own, right? Because again, we offer up something and we force a buyer to give us what we want for that asset we offered up. Number 3, we send LBTC from our elements node to a covenant derived address. So I have some helper functions that interact with the reg test node. And if you want to spin up your own reg test node, you could look at this repo. I have instructions in the README. Actually, I use something called Nigiri, which is a great tool for Bitcoin development. Sorry, I had to give this a little shout out because it's a great tool. You should use it. And all right, back to where we were. So yeah, there's some helper functions that send LBTC to our covenant derived address. And so that's what we're offering up, LBTC, by the way, here. So that's this part. We also send LBTC from our elements node to the takers or the buyers address because we want to be able to use that to cover fees when we take the offer that was broadcast. And then we want to send the asset. So this new asset is going to be what we want as a seller. So we're going to send the asset to the taker who's going to, complete our transaction to redeem our LBTC that we locked up in this covenant derived address. And then we're going to spend, from the covenant as the taker. So first thing we do here is we issue a new asset. Again, I have a helper method. It's issue asset. It gives me the asset ID. Then we create a covenant with a spending condition enforcing an asset payout, right, to an address we own. These are straight from here. Get covenant script is that function you saw before. Again, it just pieces together all these individual components. And I call trim on it because the library doesn't like any extra space at the beginning or end. Internal public key, this part has to do with taproot and key path spends. This is what will allow us to do a key path spend later on, what you'll see there if we wanted to cancel our offer. And then 3, we want to send LBTC from our elements node to a covenant derived address. So again, we want to make a sell order for our LBTC where we use this covenant script to ask for the asset that was just issued. So we're going to spend the covenant, and again, we specify LBTC, we spend to the covenant address, and then we put in the offer amount. And then it'll tell us, hey, sent asset to covenant address. Next step, we send LBTC from our elements node to the taker's pay to witness public key hash address to cover fees. Again, as the taker, we also need to pay fees on the transaction. So I just wanted to make sure that there's something that we could pay from. This is funding the fee of the taker. And then we send the asset to the taker's pay to witness public key hash address for the swap because they need also the asset that we specified we want to give our LBTC for. And then finally, we're going to spend from the covenant. And these results that we get from spending, we can use those as arguments to this other helper function called create input. So I just created the input. This is from the first spend to covenant transaction. And then this is going to be the covenant funding spend result, which is, for the fee. And then this will be the asset that we want to exchange for this LBTC that we put in input, 0. That's the spend to the covenant. And let's see, anything else here? So one thing to note is that the spend to the covenant transaction, that is an input 0. And the output here, that's an input 0. These will kind of have to correspond to each other, right? So this has to be the issuance amount of the asset ID, or else this whole swap doesn't work, just because that's what we specified in our covenant, that the same output index has to offer up the asset ID for this to be a valid swap. And here's where we have the LBTC offer amount. This will come back to us as a taker as we start assuming this role. And then here's the explicit fee that we're paying, because we also have to pay a fee in Liquid, and those are explicit outputs in Liquid. Finally, we call spend from covenant, and then we can pass in the covenant script, the inputs, the outputs, the internal public key, and the asset ID. And then we'll have a successful spend. And lastly, I'll just quickly go through the spend from covenant again, because I don't want to lose you too much. And then I'll wrap it up, and we'll be open for questions. So this is in liquid helper.ts, spend from covenant. So LiquidJS, it takes a little bit, to get used to. I think Bitcoin is generally a bit, hard for beginners to get into. So there are a lot of semantics that you should understand. One of them being these partially signed elements transactions. And again, there's some details about taproot that I omitted from this presentation that are still prerequisites to being able to do stuff like this. But again, I think having this example code and things like this might help you get a better perspective of how to do these things. So again, these leaves are, related to taproot and things that I didn't really want to get into for the presentation. Really just wanted to focus on atomic swaps. So here is where we have the key spend. You could actually put it in as an optional argument. And if it is not a key spend, then what we do is we have to put in the taproot stack. So this will actually be something called the control block in taproot, and the witness, which is going to be that original covenant script that I showed you. again, can kind of abstract it a little bit here. And if we did specify that we want a key spend, so in the else, we do something called we like tweak a private key, and this function has access to the internal private key, and you can actually spend the same transaction with a signature instead of having to match the conditions contained in the tapscript stack. So yeah, again, tapscript stack is just an array with that witness script or that covenant that we specified, and the control block and the signatures if we decide to sign it with the private key related to the internal public key that we saw when I was creating the covenant. And if we want to see it again, I want to go back to main.ts. When we create the covenant, when we get the covenant address, we pass in the internal public key. And this essentially allows us to say, if we have the private key to this public key, we could spend it outside of this script condition. And yeah, that's pretty much all there is to it. I do the input one preimage. I sign that as a partial sig. Same thing with input two. Again, those are going to be like the funding, pretty much, right? See, these are the inputs. So the funding and the asset that we put in, and then of course the covenant input. We finalize everything and then we broadcast it. And yeah, this should work out the box if you use it with Nigiri. I don't really have Docker up right now, so I can't run it, but trust me, it is very easy to run. If you have any problems or challenges, feel free to message me on Pull2, or put a post out asking about it. But these are the instructions to run. And that is all that is needed to make a simple atomic swap. Although you might want to add some extra checks and whatnot for your own use cases. Because again, this is very simplistic, just showcasing the most basic usage of these covenants. And let's go back to the end of the presentation. Thank you for allowing me to present to you. And I hope you were, I don't know, entertained or at least, educated a little bit about covenants and atomic swaps. And I'm ready for Q&A. So does anyone have any questions?
Hey, Randy, there's a few questions in the chat box on the bottom right.
Awesome. So fees are higher if you're swapping between liquid assets because you're also covering the taker versus sending one transaction. I mean, fees have to get paid on both like the offer and the like taker. So if they're a higher, I'm higher than what? If you're able to clarify that. Yeah, higher compared to what?
Just like a swap between two liquid assets, is the fee higher than, versus sending one transaction? Because you mentioned that like you have to cover the fees of the taker as well or something.
Right. You do have to put your offer out as a transaction, and then you also have to put like a transaction that takes it, maybe as opposed to the partially signed elements transaction approach. Yeah, that would be one if you just enforce it with the signature scheme, because that input could come from anywhere. So yes, doing it this way, there are slightly higher fees, but yeah, it also allows you some flexibility, like I said, about the assets that you'd like to take for one offered asset. Kind of related to the previous question, is the taker or the maker paying for transaction fees in a swap? Can this be specified in the covenant script? Yeah, so since these are both broadcasts, both the maker and the taker will have to pay fees. Yeah, it's again, the pset approach might be better with respect to that. Luckily, fees on Liquid are low. So to explain how swaps between Lightning and Liquid are working, I haven't looked at how Bolts is implementing it, but I imagine they're doing something similar to these submarine and reverse submarine swaps that I had in the diagram over here. Because again, Liquid, they have HTLCs, since Bitcoin has, or Liquid has everything that Bitcoin can do and more, of course. So this same process could work fine for submarine and reverse submarine swaps. Any other questions? So yeah, the presentations are offered on YouTube. They will be put up. I'm not sure exactly how soon after. Chase, probably like within a couple days. Right.
Yeah, within 48, we'll have it up.
Awesome. And then for two, do covenant-based swaps differ from regular two-step swaps? It doesn't matter if only one or both assets are covenant assets. So not quite sure what the two-step swaps are, but it only one asset needs to be covered, which is the offered asset when you're making a sell order, which is what I was going through here. For one or both assets. So yeah, only that one input asset that's being offered needs to be in the covenant. And then will covenant assets be allowed into the asset registry in the near term? Yeah, so that a big example of an asset that's being covered by a covenant is like Fuji Money. It's a really cool project. I recommend checking it out. And yeah, that is in the registry right now and will release very shortly. If not, already have to check the release date. But yeah. Got it. LiquidX. Yeah, I'm still not too familiar with the other protocols out there, so I wouldn't be able to intelligently answer that question. Any other questions?
All right. Well, thanks for your time, Randy. I think it was a really good introduction to atomic swaps. I know I learned a lot.
Yeah, thanks. Hopefully I'll have some follow-up presentations where I could do more stuff with covenants. If you want to, keep up with all the stuff that I'm playing around with, make sure to check Bowl 2 in the developers tab, and I try and post there somewhat regularly. So yeah, keep in touch, message me if you have any other questions. And yeah, thank you all for coming. Thanks, Douglas and everyone else.